My name is Jack Kuhr, and I'm the research director at Payload. We have a phenomenal webinar today on Agile engineering and the NASA Handbook approach, the Waterfall systems engineering approach. This is going to be as open of a dialogue as we can make it. So if you have a question, we have a Q&A box down below. Please just pepper the questions in, and we will look to prioritize those questions over my questions as the moderator. And with this is a Flow Engineering sponsored webinar. So very much appreciate it. And we're going to have a great conversation today. I want you guys both to intro yourselves. Adam, why don't you go first?
Yeah, thanks, Jack. Pleasure to be here. My name is Adam Thurn. I'm the head of engineering, chief engineer for space missions here at Anduril. I started my career as a spacecraft mechanisms engineer with the Department of Defense, working at the Naval Research Laboratory, and had the unique opportunity to work on actually a number of government systems that made it to orbit, which was phenomenal. More recently, I was the VP of engineering and a systems engineer at TIVAC, Terran Orbital, and then I've been at Anduril for about 2 years now. Really as a foundational member to figuring out how we stand up a space business line within the company as Anduril look to expand into other domains, and figuring out how we develop on-orbit systems, how we develop the interoperability with the other robotic systems and machines that Anduril is providing in other domains. And so really excited to be here to have the conversation with Pari and Jack, and looking forward to the questions from you guys.
Awesome, thanks. And Pari?
Hey, I'm Pari, founder and CEO of Flow Engineering. I'm a mechanical engineer by training, and I started my career with a very short stint at BAE Systems in the UK. So like legacy, prime, very, very old school Waterfall. And then I think I saw the light and I came over and spent a lot of my career really building tools to enable agile systems engineering and agile requirements management. So we're lucky enough to work with some of the leading companies in the world on space and agile engineering, and excited to share some of those learnings on what's worked, what's not worked, how it's different to NASA, where NASA needs to be correct versus an approach that a modern company can take.
Cool. Awesome. And why don't we just start off by setting the scene and describing the two terms that we have in the name of the webinar, which would be the Waterfall systems engineering approach and the Agile systems engineering approach. And Pari, why don't you take that one?
Yeah, awesome question, and very misunderstood as well, I might add. So what is Waterfall? Well, Waterfall is classic NASA systems engineering. Let's spend 2 years in requirements phase, decompose 10,000 requirements, build a big Gantt chart, and then execute very, very specifically on that Gantt chart. The problem with Waterfall is two things. Number one is you get requirements creep. So when you are building a waterfall program and you're building one, you've got one big shot at it, you add more and more requirements, you get more and more scope creep, which makes the engineering harder and harder, which means you have more and more requirements and it just kind of blows up. The second big thing is really around complexity. And this is something that's poorly understood. When you are designing low complexity systems, you can sit down and write down your requirements, and you can be first order approximate correct around how a lot of these requirements flow down and decompose. Now, as the complexity of our systems has got larger and larger, as software has played a larger and larger part of that complexity, and as we have more types of engineers, mechanical, electrical, software, systems, all collaborating, the complexity has blown up, and the decomposition of requirements cannot be first order approximate accurate. And we need domain engineers or responsible engineers in the loop. So what we've seen the engineering industry pivot to is an agile way of working. Now, agile does not mean 2-week sprints. Absolutely not. There is still a burn down. There is still a dependency tree inside of complex hardware systems. But what agile fundamentally means is an iterative approach to designing a complex system where we take multiple shots on goal, and with each shot on goal, we learn and add complexity. So Falcon 9 didn't start off as Falcon 9. Falcon 9 started off as Falcon 1. And Falcon 1 started off as just the Merlin engine. And eventually we got to Falcon Heavy, and eventually we got to Starship. But on every one of those iterations, we built a system, integrated it, flew it, learned, added complexity, removed complexity. And we did that in an incremental approach. we'll come back to, I think NASA's origins were actually Agile and not Waterfall. We can come back to that. But broad strokes to summarize, Waterfall is long, slow, serial engineering development over the course of multiple years. Agile is fast, in parallel, iterative development where we don't know all the answers, but we take a shots on goal approach to building those answers together.
Nice. You have that pitch down.
Yeah.
You have a great way of simplifying it. And Adam, at Anduril, is it a one or the other approach? How do you guys look at systems engineering in relation to the two different ways?
Yeah, I'll actually even take it a level higher and kind of, feed off of what Pari was saying, which is, setting requirements at the beginning of a program and doing the decomposition and being rigid in that development process does mean that as you learn things and go through your various design phases, as you test, you oftentimes want to update those requirements. And that can be a painful process if you're unable to have that iterative design approach. The traditional NASA methodology for systems engineering doesn't mean that you can't change. In fact, when I started in the Department of Defense at the Naval Research Lab, we took this very iterative approach in spacecraft mechanisms where we were designing and building and testing things very quickly. We were learning from those and we were feeding that back into the design loop and feeding back into the requirements that we needed to do. And that is the US government taking that in effect. And so really applying that methodology, not necessarily splitting hairs between which methodology is the right one, but you have to empower engineers to be able to have that creativity and that autonomy to employ what they learn in the design and test phases back into updating the requirements. So you ultimately are delivering a capability to the customer. That's actually the approach Anduril takes across all of our domains and what we're doing in space specifically as well, which is how do I take what the customer says at the beginning of the program, work closely with them, work closely with the end users and the operators, and take their inputs and adjust our requirements to meet the capability that they need. If we were rigid against that first set of requirements we'd have, the capability delivered to the end user, to the operator, may not actually be what they want. And so you have to be agile, and really that flexibility is key. And so that is, first and foremost, something Anduril does across the board, which is get our tools, get our capabilities into the hands of those end users, operators, get that feedback, and then update the requirements, update the designs to incorporate what they actually need in order to perform their job.
Can I riff off something Adam just said to go backward? Like there's two really important points here. The first is like, hey, when you live in a complex world, you want to get a product in the customer's hands as quickly as possible and learn, because sometimes the customer's requirements aren't right and they don't know what they need just yet, and we've got to go learn that. Sometimes customers' requirements are right and the world changes, and there's like a new war, or like there's a new method of warfare, or whatever that is, and we need to be responsive to that. But I think the thing I really want to double click on is Adam's amazing point around the culture that teams need to have to be successful within an agile environment. And I think he made 2 points. The first point is the idea of responsibility and who is collaborating and who are feeding back those requirements. And the second point is what a requirement is and fundamentally how that's changed. So let's riff off of both of those. The first is, at SpaceX, Elon has this rule, which is every engineer is a systems engineer. And this is a really important rule. And what it means is that every engineer needs to be empowered to, one, ideally write the requirements for their low-level component or system, but two, understand how their requirements are delivering on the global, and when they need to make a local change for the global optimum. If every single team is locally optimizing, you're guaranteed to be off global optima. So you need every single team to be able to understand what their lever does to the macro. So that's a really fundamental, important cultural element. And the word that we hear used very often among our customers is this idea of an RE, or a responsible engineer. And an RE is really a domain engineer plus a systems engineer wrapped into one. And that person is really empowered to be part of it. The second cool thing here is that the word requirement really doesn't mean what it meant 30 years ago. And it kind of, the idea of requirements evolved. Requirements originally came from like hard vendor contracts, where you had like a legal document and then you had the requirements inside the legal document. They were very wordy and verbose. They were static and they could never be changed. And what a requirement is really turned into, like especially a lower level requirement, are these design parameters that are regular, that are assumptions, that are our best indication early on what this might be, that change on like a nearly like daily basis, especially early on in the design phase, as we're working out how all these different systems interact. So big plus one on like the cultural elements to Adam's point.
Yeah, no, Pari, you say it perfectly, and it's exactly what we adopt as well, which is everyone needs to think like a systems engineer. If you are an individual contributor working on a project of a complex system and your widget is amazing and great, but the system doesn't deliver, no one actually cares about your widget being amazing and great.
Exactly
The
right.
system is what needs to get delivered to the end users.
Yeah.
Great. The another thing I wanted to dovetail off of something that Adam said about the working with the DoD. I know this is a NASA focused webinar, but Adam, you worked at the DoD or with the DoD. You said 10 years ago you were working at the DoD.
A little more than 10 years ago, to date myself a bit.
Yeah, so that's interesting. So you made a comment that even 10 years ago, the DoD did, maybe contrary to perception or an onlooker's idea of what the Pentagon's risk approach and risk appetite is, but even 10 years ago, 15 years ago, you're saying that the DoD did have kind of this appetite for an iterative approach, an agile approach. Just curious about how that maybe has changed over the 15 years. Why perhaps is there an impression that the DoD is more rigid? And if you could just kind of talk about the dynamic.
Yeah, for sure. I think I was incredibly fortunate to be in an area at the Naval Research Lab within the DoD that did provide that flexibility to use the more agile approach to design iteration, to testing, et cetera. I think there are acquisitions out there that tend towards Class A missions that do inherently provide this level of rigor that's needed, and the belief is that you can only get to that mission assurance by following these rigid requirements decomposition, where everything is set in stone at the beginning so that you know exactly what you need to design, exactly what you need to analyze, and exactly what you need to deliver. And it doesn't allow for that creativity through the process. Ultimately, a lot of those programs, given the complexity of them, tend to drag on for many years. And the thing, as Pari mentioned earlier, that you started 5, 6, 7, 8 years ago may not be the thing you want nowadays. And that's because things have changed. And so I think getting the customers to understand the iterative design cycle and how at the end of the day you're going to provide a capability that meets their needs, which is ultimately their goal. They are not incentivized to say, no, you must follow this rigid contract. That gets into the whole contracting side of this, which is another topic for another day, I imagine. But it does allow us to, be able to iterate on those, be able to apply that methodology, and be able to give the customers what they want. I think my time at NRL was unique in that, and I wasn't burdened by some of the more traditional government approaches. But I do think, a lot of what Anduril has been doing in the last 8 years is focused on working with those customers to show them this methodology, show them that, this approach can still yield and deliver results for them. And we can actually put capability in their hands faster and with more effectivity towards their mission than what their traditional approaches were getting them. And it's both sides working seamlessly together. A great example we have at Anduril is on our collaborative combat aircraft program, where we have the government program team sitting side by side with the Anduril engineering team, with the Anduril program management team, and working closely together. They're part of our design cycles. They're part of our tests. They're seeing things. They're providing real-time feedback, and we're able to iterate on that with their inputs and ultimately provide, those aircraft ahead of schedule.
Adam, can I ask you a question on that? I'm fascinated by this. So like I think historically people imagine like there's the agile world and the waterfall world, and like the DoD tend to be very like taxpayer funded, slightly more conservative, quite rigid. So people assume that they're over here. But what I've heard from people and our customers is they're starting to see the light and they're starting to move over. Can you talk a little bit about what you think is driving that? And if that's accurate, if you disagree, please say. And what you guys can do as a customer to help them see the light faster.
Yeah, I do think we're seeing those changes and seeing the customers be more receptive to these types of approaches that at the end of the day, again, I mentioned it before, what they care about is you delivering a capability and a result for them that gives them what they need to execute their mission.
Yep.
And the approach by which you get there, as long as the focus is on mission assurance. And this is a little bit where the approach that we take on our space team here at Anduril is, iterative design cycles don't mean that we lack mission assurance or that we don't care about on-orbit success or the success of the systems we're applying on weapon systems. Those things are still first and foremost and at the front and center of what we're trying to do. And so that's what the customer needs. That's what we need to deliver. We need to work with them to make sure we're pulling back the curtain so they see the process by which we're executing on our engineering efforts, both on hardware development, on software development, and then ultimately at the system level, and being able to provide that. Once they understand that they're getting capability in this approach and that we are actually meeting requirements, albeit in a slightly different methodology, they tend to be very open and receptive to continuing that process. We have started programs on our space business line where we had customers who took a leap of faith with us to execute in a managed by our Jira software board. And they were skeptical at first, but a month or two in, when we showed the success we were having and we showed how far we were accelerating ahead of their planned schedule, they were like, yep, never mind, we're all in. We're going to buy into this approach and we're going to let you guys keep running. And they appreciate the fact that we're providing them insight. The customer has access to our Jira board. They see our sprints. They see the work that we're doing. They see the tests and the demos. And that is critical, is the customer is part of the team. They're not just an entity on the other side. Bringing them into the team is a huge benefit to them.
I think another point that makes Anduril really special is the fact that like you guys pay for your own R&D a lot of the time, and you kind of have it. How does that change the dynamic when you go to a customer and you're like, hey, here's a V1 and we built it and it exists?
Yeah, it's incredibly unique, and I find myself incredibly lucky to work at Anduril because we're able to do things like this where we can take a V, call it 0.9 and say, hey, customer, here's what I've got, and then additionally, being able to extend the work that we're doing within the contract because the customer needs something new, or bring in new data streams or provide new capabilities, and do that within the scope of the contract. Because at the end of the day, the more times we put our Lattice software in the hands of users, the more people who are using it, the better it's going to be, because we're going to be getting that feedback from it. And so I think that ability to say, yes, we're going to accelerate our programs with R&D, we're going to understand a problem and we're going to get after it, is key, to the Anduril business model. The excellent example of this is the Roadrunner kinetic kill vehicle for the counter UAS mission. That customer had a single high-level mission requirement, which was to defeat the increasing capability of adversary UAVs. And we didn't have a capability to do that. Anduril took that from a concept design to fielded operationally in less than 24 months. And we really only ever had that one high-level requirement, which was, how do I go defeat increasing capability from the adversaries on their incoming UAV threats? And that was it. And we went and designed a system around that kind of single high-level mission requirement. And that allowed us to move, incredibly quickly and get that fielded. And now we're seeing the success of being able to show the customer, here's the thing I have that you can now buy, and they're happy to do so.
Well, I think you've made a subtle but really important point. And let me go the long way around on this. But I think if you look at the arc of history and you look like 50 years ago, or you look 50 years into the future, they're both agile. And we're doing this loop from like agile to, and we've gone to waterfall. And I'd say like shuttle was peak waterfall, like it's as waterfall as it can get, and things didn't go great. And now we're the pendulum swinging back to agile. And when I look back 50 or so years, and 60 years to the Apollo missions, like there was one top level requirement, which is like JFK goes on stage and he does this big rousing speech and he goes, we're going to put a man on the moon and bring them back safely in the next decade. That was the top level single requirement for the mission. But how we got there wasn't by building like all the requirements for Apollo 11 or whatever. We actually did it in an agile and incremental way. Like when we went to the moon, we didn't design one big rocket. We actually took 3 stabs at it. It wasn't Apollo, it was Mercury, Gemini, Apollo. Mercury, we got an ICBM, basically a missile, and we strapped a human being to the top of the missile. God bless that person, and that person went to space. And then we learned some stuff, and we said, "Hey, we humans can survive in space, and this is what we've learned." And then we said, "Hey, can we do two stages? Can we put two people in a rocket, and can we do like in orbit transfers?" And that's what we did with Mercury. So we learned a whole bunch from Gemini. We went to Mercury, and we added capabilities over time, and we learned from it, and we made things safer and safer. And then eventually we went to Apollo, right? And eventually we had three stages. We were able to get to the moon, land, and come back. Now that story is riddled with like failures and learnings and sometimes fatalities. And there are huge lessons we can learn from how we keep people safe when we're flying them in agile missions. But I think the core idea I want to share here is when we went to the moon and we did it at this incredible pace, we did that in a fundamentally agile way. And the person doing that was NASA, you know? So NASA was agile. And then the pendulum swung all the way here. But when I look back to the future and I look at the Mars missions, it's really clear to me that the way we're going to do this is through an agile methodology, even though it may be taxpayer funded.
Yeah, I think to kind of continue to riff off each other a little bit here, I think there's an element of, when you are successful and you want to codify that success, you tend to codify process. And that's not necessarily what made you successful. It's the people that were executing. It was the ability they had to deliver creative solutions that enabled that success. And really what you want to do, to have a successful company is codify the people. They're the ones to build around. You need to provide process in terms of a framework to give them guardrails so that you reduce variability in your design to design from program to program or your build to build, but not over constrain the process. Give them the autonomy, the creativity, the extreme ownership to be able to deliver capability. And that is really key here. And that does mean there is a risk posture that has to be understood. But that risk posture needs to be, a ground-focused risk posture where we're doing all of the testing we can and iterating quickly on the ground such that we can ensure mission success when we get to putting things on orbit.
What you're describing is literally, so I think everyone knows the NASA Systems Engineering Handbook. Like if you come to systems engineering, this is the Bible. For those of you who don't know, it's a handbook. It's about this fact. And it's both the most amazing piece of literature on systems engineering, but it's also extremely process orientated. And it's really like, how does NASA burn down a systems engineering process for a massive mission? It's not the essence of what makes systems engineering special. So what we're doing at Flow, and there's a quick plug for Flow, is we're building an agile equivalent to that NASA Systems Engineering Handbook, sort of a conceptual and philosophical counterweight, where we say, hey, what are we seeing the best systems engineering hardware teams in the world doing in an agile way, and how do we like get to the essence of it? And what makes it really hard, like from the flow side, to try and do is people really want a flow chart. People love a flow chart, and people are saying, hey, can you just add more detail and give me a breakdown of steps? And it really comes back to what Adam said, which is, hey, it's more about the people and building the environment in which they can learn and take ownership of stuff and iterate and like continuously make that better and better, and less about a specific burn down of a specific process. But I think we're seeing that come back, which is awesome.
Yeah, fully agreed.
Yeah, how much of this kind of risk forward tied in with agile engineering is married to broader societal and cultural moments? Like, is it that like in the 1960s, we had more, the Americans just had a more risk forward appetite because it was the first, when we had Apollo, it was the first mission to the moon. But maybe in retrospect, we kind of in the 80s looked at the future Apollo missions going up to Apollo 17 as maybe a little bit too risk forward, and the appetite kind of changed a little bit, and the broader culture of the moment called for a slowdown in taking kind of this risk posture. And maybe we are coming back into more energy just in a broader cultural moment where people said, hey, maybe that stifled innovation to a certain extent, and we as a society want to kind of push the gas pedal down a little bit. Do you see that as kind of relevant here, or do you see it as or do you kind of take a different approach to it?
Adam, what's your take?
Yeah, I think during the early days of Gemini and Mercury and Apollo, right, we were learning, and so we weren't maybe necessarily completely aware of all the risks of putting humans in orbit. I think as we learned on that, we became more risk adverse to that, and there is certainly a price to pay with putting humans on top of rockets and sending them to orbit, and the rigor that has to be done for manned space flight, and there can and should be a difference in how we approach manned space flight versus unmanned space flight. And I think as we continue to learn about the risks associated with putting humans in space, we started to become more risk adverse, and then unfortunately I think some of that risk aversion started to bleed over into the unmanned systems as well. And that kind of led to what was mentioned earlier by Pari, which is the cyclical systems engineering approach, where we continued to lean into the risk aversion, where we needed to conduct, huge amounts of analysis to prove that our requirements were right, to prove that the design was right. And we got scared of being able to build and test and deliver things. And I think we're just seeing the other side of that now, where we're starting to realize that we, started to fall behind in our ability to deliver systems and capabilities. And, we are seeing, peer competitors that are providing that and the approach they're taking. And as a nation, we have to change the way we're doing things, otherwise we will continue to be set back.
I think there is an emotional answer and a logical answer. And like my academic textbook brain is kicking off with all the logical reasons that'll explain this. But maybe I'll start with the emotional answer and then go to the logical answer. The emotional answer is, I think you're right. I think people naturally tend towards comfort. And when there is peacetime and things are going great and you're number one, there is no reason to take more risk.
Yeah.
So in times of like static, good, happy periods, it's very, very, very easy to lose discipline. It's very easy for programs to be a year or two late and there not be a problem for that. And it's easy to lose the essence of what made a country and a company special. Now, when there is a gun to your head and there is pressure from an external force, whether that force be a commercial force or like a country, suddenly people get switched back on. So I think what we saw in the US is we saw the responsive space program with Firefly and I think Rocket Lab coming together to put a satellite in space in 24 hours. Now that doesn't happen unless you're worried about needing to put a new satellite in space if one of your satellites gets deorbited for whatever reason, you know? So there is a cultural moment around an external prompt driving the need to be better at your game than you were before. Now, that being said, I think from a logical point of view, the fundamentals have changed. And what do I mean by that? I think there are like 2 or 3 fundamentals. The first is the products that we build today are massively more complex than the products we built like just 10 or 20 years ago. I kind of see this as 2 buckets. I see the bucket of products and the bucket of systems. And as things get more and more complex, more and more things move from products to systems. A Rolex watch is a product, an Apple Watch is a system. A fridge is a product, a smart fridge is a system. But like even on the space side, as satellites get more and more complex, as software becomes a larger and larger part of that satellite bus, things get massively more complex. So complexity has increased. The cost of test has gone down. Apollo was a bit of an edge case because we poured billions and billions and billions of dollars into physically testing stuff, and we could get away with that because there was a war. But now with simulation and with the sort of lower cost of manufacturing and test, we can actually afford to not overthink and just build it, test it, see what happens, iterate again and again and again. So I think you've had this massive increase in complexity, a massive reduction in the cost of test, and then a commercial driver, which is a lot of these new space companies are VC backed, they're not government backed. There is a problem around time to market. If you spend too long thinking, you will lose the war, you will lose the race. And when those 3 things come together, you have a really special concoction of time to market wins, We need to build and learn, and it's cheap enough to do that without overly getting stuck in analysis paralysis. So yeah, there you are, textbook and emotional answer.
That's great. Yeah, I'm hearing more and more that the number one decision, particularly amongst government customers, the number one decision maker as to if the government is going to go with one company versus another is time to market
Yeah.
and certainty of delivery. And it's just maybe for years and decades in the past, there's just been burned time and time again on that. Even more than the cost of it. We do have a lot of questions in the chat. I want to do kind of a rapid fire through them. I'll start with you, Adam. This is an interesting question. Say you have a fresh program awarded. As a chief engineer, what are the first 3 things you do to start the Agile process with your team?
Yeah, I think first and foremost, it's really understanding that mission level requirement, right? What is the current capability or capacity or the result that the customer is looking for, and then getting the teams together to make sure we are all aligned on that top level mission requirement, and then really asking the individual teams to go off and decompose into, you know, an architecture and a capability that they want to provide into that and how that fits into the system. Getting that initial systems architecture block diagram correct, identifying the interfaces between the different echelons that you're going to create is incredibly important, because it enables you to go develop and be able to deliver things into the system if those interfaces are well understood and well defined. Now, that doesn't mean that you rigidly define those and you never change them again. You have to be able to adapt and flex to those as, you know, new in the software architecture, as new services want to split into multiple services, or you want to combine things into a single service, that will change things. And so getting each of those teams on the software, on the hardware side, to collectively figure out how they want to tackle the problem and bring that all together, and then start to take those and decompose those into what are the demos and at what periodicity do we want to be conducting those demos so that we're getting that feedback loop internal to the team. When do we want to get demos in front of a customer and being able to drive to those capabilities, because a PDR, a CDR is great to drive to. They're huge events typically for these complex systems. They take oftentimes months to prepare for. But there's nothing against those that says you can't be also doing iterative design reviews and tests throughout that process, such that you're not lumping everything into that CDR. You're getting that feedback real time throughout. And so identifying those demos and sticking to them and providing that capability, whatever it is then, so you get feedback on it, that is crucial to maintaining that schedule. And so those are some of the things I would start with on the program. And then, you know, once you start executing, it's that customer feedback. It's that the customer is part of the team that is so crucial to be sure you can adopt and change demos or change timelines or change, you know, the requirements by which you're developing. So that's how I'll start going after executing.
Can I ask you on that, like when you're working in this agile way, you've got this team that are all running in parallel. Two questions. Question number 1, like what's the hard bit? Like clearly this is right, but clearly this is more difficult to do than a traditional waterfall program. So question number 1 is like, what's the hard bit? What do you struggle with? And question number 2 is what do you think the role as chief engineer changes from a waterfall to a more agile process?
Yeah, I use the analogy with my team all the time, right? If I'm standing at a point and I look around me and there's, you know, 360 degrees of possible solutions to go after, there's tends to be more wrong answers than right answers. And so you have to have that initial system level architecture and design process to get everyone loosely on the same page, such that when those individual teams start vectoring, they're moving generally in the right direction. That doesn't mean they're directly on the, you know, line from A to B that is the shortest distance. They may, you know, it may be very zigzag to get there. And that's okay. That's the point of the iterative process, is start developing something, get it into the hands of the testers, of the users, of yourself, you know, iterate on that and continue to re-vector yourself towards the solution. That initial kind of kickoff of a program can be a bit chaotic. And that's mostly because everyone is in a learning phase to an extent. You are collecting data, you're getting things on paper, you're putting ideas on the whiteboard so that you can cross off the ones that aren't the right ideas. And then I think as the role of a chief engineer there, right, it is ensuring that those teams have the collaboration across them, that they're communicating, that they're not stovepiping their results, that they are indeed thinking in that kind of responsible engineer, systems engineering mentality on my thing needs to interface with this other thing, and it is going to have to perform this capability. And if we don't understand that data management workflow, the command and control workflow there, and how that feeds into the hardware when you take this kind of Anduril software first mentality and approach, how the hardware has to support that capability. That's the role of that chief engineer, to make sure that all of those pieces are moving in the right direction, right? Everybody's running on the same track and getting, striving toward that finish line.
I love the line of vectoring. I'm going to steal it from you, Adam, because it's so true. It's like, I think people really want, here's the first step and the second step. Here's the exact trail you go through. And Waterfall gives you that. But when you're in Agile, it's kind of like herding the cats and trying to get them vectoring in the same rough right direction.
Yep. Yeah, it is, the first couple of sprints, or the first couple of development cycles, everyone's going to be all over the place. And as other teams start to see what's being worked on and come towards, higher level system solutions, everyone starts to converge.
Absolutely.
There's a couple of questions in the chat on in negotiating hardware engineering lead times. Here's one question: in industries where hardware lead times can span years, how do you apply agile principles like fast iteration and continuous feedback without losing alignment with long-term physical or program constraints? Pari, you take that one?
Adam's the chief engineer. He should take it.
Okay.
Oh, good diversion there. This is great. I think Anduril has really taught me something in my 2 years here, and it's something I never experienced in any of my previous roles, which was our software team is leading our development, right?
Yes.
We have a software platform team at Anduril to leverage, which means I'm not starting from zero on any of my software development. That means that the demos that software is doing are ahead of the hardware development cases. That's not typically the approach at really any other aerospace company or many other companies in general. And so when you have that software leading there, the hardware does have to catch up. And yes, there are lead times associated with getting hardware, especially when we talk about it in the space applications, where if you do need to go towards rad tolerant, rad hard designs, not saying that that's the answer. There are certainly commercial approaches to flying electronics. But you do have to kind of have that catch up, and you do have to understand where the hardware fits in. And that same approach to the iterative process to get you there, you may have to, bite the bullet and buy some long lead procurements up front with the idea that you're going to use those. And you also need to be okay with the fact that you may not. It's still going to be cheaper to get to an answer by doing these iterative design cycles on your hardware as well. And so build the hardware, get breadboards, get your dev boards in, test those, load the flight, or load the firmware and the software onto them and see how they perform. Start to combine those into the system level tests. That is key. And so we're not going to get away from it, right? There are lead times associated with some of these components, but you have to figure out how you can develop and work with those suppliers and potentially even use lead time as a factor in your design. If hardware lead times don't support the delivery, then you may need to look at alternative devices. That needs to be in the engineer's playbook.
Let me just expand on two of those points. So the first is, when I say people misunderstand Agile, this is one of the really important points. Agile is really about iterations and learning per iteration and adding capabilities over time. But inside of Mercury, as an iteration, there is some waterfall, right? There is some like natural dependencies, especially when you've got physical lead times on systems. Now, I agree 100% with Adam that, hey, if you can, try and pick the one that gives you the most flexibility. Because if you build something with a lead time of 5 years and you're shipping in 5 years, it's not going to be an agile program. But you've also got to be really comfortable with the idea of minor waste for macro failure, like micro waste for macro failure. When companies look at agile companies, they're like, oh, everyone's working in a different direction. You've got all of these scrap metal, you've got all of these things that you manufactured that you're now wasting. Like, this is super inefficient. But then you look at the overall development cost of the program, and it's a quarter of the cost of a traditional NASA program, right? So I think, especially the new breed, that we need to get really comfortable with the fact that not everything we're going to do is right. There is going to be some waste in this. We've got to get comfortable with that fact, but really optimize for development time, because that's the single largest factor in the overall program spend.
Awesome. There's a question here that I like. It's on the potential pitfalls, perhaps, of agile engineering. The question and is well, he starts off with saying, I've worked at NASA as a system engineer and currently a system engineer on a DoD complex system of systems program. I have seen both great and bad uses of each method. From my perspective, some DoD programs are so strongly opposed to Waterfall that they have overcorrected when converting to Agile. I think Agile isn't well understood, and I've seen Agile be treated as, quote unquote, do whatever the customer wants whenever they want it. It has led to significant and constant scope changes and creep. It's very chaotic and difficult for our devs to manage. Have you seen any of this? And if so, what do you think is an effective way to navigate that issue for agile programs?
Yeah, Pari, I'll let you take that one.
All right.
Running.
So 100% agreed on problem space, by the way. I think agile is one of the least well understood terms, and it's people use it vaguely. Like, sometimes they're like, oh, everything is about 2-week sprints. So we're going to build a big Gantt chart and then do it in 2-week sprints. And that's agile. And 100% that's not true. Sometimes we say we're going to have no plan and no requirements and see what happens. Also, not the right way of doing this. I think best practice is really a combination of both top-down and bottoms-up systems engineering. So you always have to start top-down with capability, right? Like as Adam said, for Roadrunner, we knew we had one top-level requirement, and that's the thing that guides everything. But there's a combination of top-down coming from decision maker, a regulator, a customer, whatever it is, combined with what can engineers deliver, and how do those bottoms-up deliveries and those capabilities connect to the top level. In terms of like process and culture, I think this is just one of those things which is hopefully we will mature as an industry. At Flow, we're certainly trying to do our part by building this Agile Systems Engineering Handbook and writing more and more content on best practices and what we've seen work and not work. So yeah, I don't have a specific answer on like when people are out of whack, how we fix that, but we're certainly trying to do our part. And if you have ideas for us, we'd love to help.
Awesome. We have,
Yeah, and then
yeah.
Sorry, Jack, I'll add on to that a little bit, which is I think we shouldn't get over prescribed in the definition of Waterfall and Agile, right? They are frameworks, they are methodologies to burn down development risk and ultimately lead to mission success. The implementation of those, the framework of those, that is the key. And not doing so such that, again, you get into that rigidity of program execution, but having the flexibility. And so, to Pari's point, people use Agile and it means any number of things to any number of people. But it's really how you enable your engineers to provide their autonomy, their creativity towards solutions. And doing so can have a waterfall effect. It can have an Agile effect. It can have combinations of the two. And there's always going to be elements of that. It's really providing that framework, as engineering leadership, being able to provide the team with the right guardrails, as I mentioned before, to go execute and be successful.
Awesome. And there we have around 10 minutes left in the webinar and a bunch of questions, a lot of people attending. If people wanted to reach you guys, we're not done with the webinar quite yet, but if people wanted to reach you guys, is LinkedIn a good place for both of you guys?
I'd say
Okay.
LinkedIn is great. Also, Pari, Pari at flowengineering.com. Feel free just to email me.
Okay. And Adam, would you mind giving your email?
LinkedIn is great.
Okay.
Perfectly.
Awesome. Okay, another question. This kind of goes back into NASA and slightly kind of covers the new budgets that have been proposed out of the White House and how to apply agile engineering within it. But how do you apply agile principles to an agency like NASA, where they are under the scrutiny of Congress and meeting the expectations of never failing. Companies like SpaceX can iterate, design, and fail fail to better learn where the boundaries are. Initiatives like Apollo do not work with budgets that NASA has now and going forward. Let's take this one.
Yeah, I'll start at least. I think I want to make sure we don't confuse agile methodology with a decrease in mission assurance, right? That is certainly not the case. In fact, I think you can maintain that same mission assurance for success on these NASA programs that do have that are the marquee programs where they can't fail because they are, potentially the waste of billions of dollars of taxpayer funding. And so it is just a different approach of how you get to mission assurance, how you get to mission success. That, at the end of the day, is still the number one thing we hold ourselves to. SpaceX was its own customer. They were willing to fund those failures. They did so very publicly, whereas a lot of companies probably don't put cameras all over their rockets that may blow up. And so, here at Anduril, right, we have our own test ranges. We are taking prototypes of our capabilities out to the ranges. We are testing those. We are getting flight data and we are iterating on those. Some of those are successes, not all of them. We learn from those failures and then are able to go and provide that capability to the customer. You can do so within the context of even a traditional NASA program where you are developing and testing, modules and smaller subsystems to buy down risk that will ultimately lead to successful on-orbit operations. So I want to make sure we don't conflate the two of, agile means taking on more risk. It really doesn't. It's just it's a different way of burning down that risk.
Yeah, I'd even go as far as arguing the most, as far as I understand today, the safest launch vehicle of all time is Falcon 9. And they did not develop that in an agile way, and now they land a single Falcon 9 rocket like 30 plus, 40 plus times, and it's incredibly safe. So I'd even go as far as arguing, hey, the way to get to safety is to really understand your system and build flight heritage, which means you almost need to do it in an agile way. And in the future, the safest systems in the world and the programs with the highest mission insurance are going to be programs we've done it again and again and again and again, and we just know that inside and out. I would also challenge the question a little bit. I think if you look back 60 years, the space race was agile. I think if you look forward, even to like something like Golden Dome, which is very well publicized today, Golden Dome, look online. It's a new program that the DoD is looking into. It's a very large program. We're talking in the tens of billions of dollars at least. That will be taxpayer funded. TBD on who the vendors are that are going to be doing it. But I think it's deeply unlikely that it's going to be a 20-year program, which is going to be done in a waterfall way. I think the execution of that program, even though it's taxpayer funded, will largely be done in an agile way if we're going to get there on time and at pace.
Great. Another question with Agile, maybe Adam, I can toss this one back to you. How do you avoid too many iterations to meet all of the many requirements? For example,
go ahead. Sorry.
For example, how does Agile give a shorter time to delivery than Waterfall?
Yeah, and this is the plight of the engineer, right? We will work on something forever because there's always something we believe we can make better. We could iterate forever and never deliver. And at the end of the day, the way I think we approach this is the iterative cycle of getting capability in the hands of the users and the operators. Even if it's an 80% solution early on, gives them something. How you meet it at the end of the day, is really just giving them something. Something is going to be better than nothing. Better is the enemy of good enough. And then once they have it, continuing to sustain and be able to update software and update their capabilities is also crucial. This is a huge component of what we do with the Sentry Towers and the counter intrusion mission. Is we are actively collecting data on the real-time environments and updating the machine learning algorithms that are doing the object recognition and automated tracking to better inform those operators on their mission. And so there needs to be that open, honest conversation around what you're delivering for the customer that meets their high level mission requirements. And you need to be continuously delivering them capability. And then, end of a program, ideally you have iterated enough to where you've met the requirements. That is the goal. That is what you strive for. That is how you develop that quickly and continue to feed those in. And then ideally, if there's a sustainment phase, you're continuing to update that. The program doesn't end just because it's over or whatever, but you do need to be working with those customers to understand what it looks like beyond. I've made my widget, here you go. Potentially that's all good enough, but ideally you maintain that customer relationship.
I was getting a tour of a friend's office. This is like a tier 1 Agile company in El Segundo, who have raised hundreds of millions of dollars. And we were speaking about this exact problem. And he gave me a line that I'm going to use a lot. I'm going to steal his line. Thanks, Jonathan. And his line was, NASA are fixed scope, variable timeline. We are variable scope, fixed timeline. So the most important thing for that company is to get something in space. To get something in space on this timeline, and that's the launch window. We've raised VC money. We will run out. We need to hit this milestone in that time. And then exactly what fits on the bus and exactly which secondary or tertiary capabilities that we have on there are variable, but they're going to work really, really hard. I think once you give engineers constraints, especially the constraint of timeline, they will work in order to try and build the best possible thing. But I think you have to put a line in the sand, and that line should not be scope. That line should be time.
Right.
I like that as well.
Nice.
Here's another question. How do you guard against regulator capture, particularly as you're blurring the boundaries between customer, supplier, and regulator? Pari or Adam, you want to take it? Pari?
I'm happy to take it. So this is Flow does this really well. So this is a great plug for Flow. If you're in the world of having fixed customer requirements and fixed regulatory requirements and deeply variable internal requirements, that's exactly what Flow is built for, and this is something we do a lot with our customers. What I will say is the way to think about this is you have real requirements and then you have desirements, and these two things are very, very different. Real requirements tend to be things like customer requirements that are very fixed, safety requirements, and regulatory requirements. And these are shall statements, and you must be safe. Like if you hurt somebody or you blow that thing up, that's a fixed hard constraint requirement. And you want to minimize the number of those, but like if you're building a nuclear reactor, or you're building a spacecraft, or you're building a weapon system, you've got to keep those in mind. I'd say the vast majority of requirements that stem down from those are internal design requirements, and you should not consider them as requirements. You should consider them as design variables that change on a regular basis, like a temperature, a pressure, a thrust. Those aren't requirements. Those are assumptions that you're calibrating very, very, very quickly. And how you do that is to do with culture and to do with tools and to do with process. And if you're in that spot, you should come talk to us, and we should give you a demo and show you how other customers are doing it.
Cool. All right, last question. This conversation is about NASA, and we talked about Mars a little bit, but I want to get your take. Maybe I'll start with, I'll toss this one to Adam on timeline to Mars. You used to work in the space world. You know how difficult it is. We now have SpaceX who's leading this push amongst other companies that are using this iterative approach. Can we see something along the lines of Apollo to the moon, or is Mars a different ballgame?
Yeah, I'll probably give a non-committal answer here, which is, NASA is sending, rovers to Mars, every few years, right? And there's a number of vehicles traversing the Martian landscape today. And so, the next step to putting humans on those transits is certainly within the realm of our technological capabilities. And again, I think it is the open, honest conversations with what is our risk posture for doing so, and how do we burn down that risk for sending humans to Mars. And so I think those conversations and an understanding of what that aversion to risk is, such that we can be successful, it could absolutely happen in Apollo timeframes. The technology is out there. There are innovative companies willing to push the needle on this. But we do have to have the understanding that it is a risky endeavor, and how we tackle that, I think, is key. But I think from an engineering perspective, a technology perspective in this nation, I think we are more than capable of doing so.
I'll give a deeply philosophical answer to a literal question, which is when I was a kid and I used to look at technology, like everything from the pyramids to like the computer and the internet, I think it's very easy to think that technologies are inevitable and deterministic, and like humanity is going to invent the computer. It's just a matter of time of whether we get there and whether we don't get there. Humans are going to go to the moon. They are going to go to Mars. And now being on the other side of this equation on building technology, I think what's really clear to me is it's not inevitable, and it requires an incredible amount of work from the right people fighting the good fight day in and day out. And I think 10, 20 years ago, we were not on a path where we were going to do Mars because the competence and the culture and the motivation weren't there. I think if you look at the industry today, we're in a very, very different position. My gut says this is going to happen. It will happen in the next 10 years. But it's going to happen by people fighting the good fight and working very, very long hours on very, very hard problems again and again and again. And if we're able to continue that good fight, we'll get there.
Awesome. That's a great way of summing it up. I want to thank first the audience for tuning in. If you guys have any follow-up questions, we have a lot of questions still in the chat. You can reach out to Adam and Pari or myself on LinkedIn. Pari, what's your email again?
My email is Pari, Pari, at flowengineering.com. And just a quick plug for Flow. If you are doing Agile or you are doing systems engineering and you have domain engineers, mechanical, electrical in the loop with the requirements, and you have a problem around that, we would love to talk to you and give you a demo. Feel free to reach out to me directly and we can get a demo sorted out and teach you a little bit about how the best companies in the world are doing Agile systems engineering.
Awesome. Great. Well, thank you too for joining today. This was a lot of fun.
Thank you, Jack. Thank you, Adam.
Thanks, Jack. Thanks, Pari.
All right. Take care, guys. Bye.